So this topic is also in measures of variation. So another way we can compare things and measure things is what we call the coefficient of variation. So in your PowerPoint, you may have came across this coefficient of variation. So what this kind of says here is to compare variation in different data sets, you can use the standard deviation when the data sets use the same units of measure, have means that are about the same. For data sets with different units of measure or different means, use the coefficient of variation. Somehow it says different units of measure. So sometimes things don't have the same things going on here. So we have the coefficient of variation, or CV, of a data set describes the standard deviation as a percent of the mean. So this is actually going to be expressed as a percent. So they have this formula here. Sigma, remember, stands for the standard deviation and divided by the mean. And this is for a population. And then we had, for a sample, we have S divided by, or again, this is standard deviation divided by the mean if we're using like a sample. Now remember, multiply by 100% just means move the decimal 2 places to the right. If you're using a calculator, you multiply by 100, but you got to stick on the percent symbol yourself. So we have this question here. We have a sample annual salaries in thousands of dollars for entry-level architects in Denver, Colorado, and Los Angeles, California are listed. Notice how it says sample. So it tells me I'm going to be using this S over the mean, X bar. Now remember, using the calculator, mu and X bar are the same thing, but sigma and S are not. So using the calculator, I'm going to put these both into the calculator as I'm going to make list 1 and list 2, so I have that all in there together. So again, I'm going to edit, so I'm already there, so I can just hit enter. Again, I can just move my up arrow, hit clear. That'll remove all my data, come back down. So the first column, the list 1 will be the Denver salaries. And again, this is in thousands of dollars. So this doesn't mean $40.8. That actually means $45,800. Because remember, in thousands means you actually have to move that decimal 3 places to the right to get it back into the thousands notation. So I'll go ahead and put these numbers in: 45.8, 46.4. Kind of get the drill. So I'll pause the video for a second here and put those in. So I've got list 1 completed. So now I'm going to use my right arrow. I'm going to come over to list 2, and I'm going to start putting that data in. So 56.7, enter, 50.6. You can also use the down arrow to move down if you've been doing that. 56.0. I don't need to put the 0.0, just 56 is probably it's going to show anyway. 56, and then 48.5. So I think we're about there, 46.3. So I have both data samples into the calculator. List 1 represents the Denver, and list 2 would represent Los Angeles annual salaries for entry-level architects. So it looks like architects make some decent money. It's just starting out. So in this day and age with construction, it's not a bad field to pursue if that's something you're interested in. So to do the sample, we're going to use this S over X bar times 100%. Really, what I'm going to just use is S over X bar. Now, so remember, to do that, though, I actually have to calculate the data. So under statistics, I got to go to calculate, choose var ones. I'm going to keep this as list 1, so I'm going to focus on Los Angeles to start with. And I'm going to have this X bar is, again, that's the same thing as mu. So, or this right here, this Greek symbol mu. But right now, though, X bar is really what we got. That's going to be that value. And then the S is going to be this capital S here, S of X equals this 4.48 thing. Now, remember, I can actually use the calculator and I don't have to sit there and write all these numbers down. I can actually find these symbols on the calculator. So remember, under VARs, I can find those symbols under statistics. So I need this S on top. So remember, that's number 3. SX is actually the standard deviation. So I'm going to choose number 3 there. And then I'm going to divide that by, hit VARs again, back to statistics. And I'm going to use the mean. So that's X bar. That's number 2. Hit enter. Now, a lot of times they want us to round this to one place past the decimal. So what I got to do right now, though, is I got to write this as to 4 decimal places. So I have for Los Angeles, or for Denver, I got 0.0973. Now remember, I'm going to be moving the decimal 2 places to the left. So it's going to be like 9.73%. So I got to decide now, 9.73%, is that going to stay as 9.7 or is it going to round up to 9.8? Well, since there's a 3 there, that means just to keep it as a 9.7. So that's going to be a 9.7%. That's going to be the coefficient of variation for that. So it's going to be Denver. So I'm going to put a little D up here for Denver. Now I can turn my attention to Los Angeles. So going back to stats, though, calculate. We are still doing one variable statistics. But notice here I got to change L1 to L2. So L2 is right above the 2 down here. So I hit the second button, hit L2, and this all goes together. And that gives me my calculate. So now I have this 52 and 4.67 thing. So again, I'm going to let my calculator do that math. So under VARs, again, our formula says S over X. So 5, I'm going to choose this S of X, which is number 3. And I got to divide that by the mean, the X bar. VARs number 5. Mean is number 2. So that's going to be the standard deviation divided by the mean. Hit enter. Again, if you don't want to move the decimal 2 places to the right, you can just times it by 100. This is going to give you then like 8.833%. So this 8, oops, come back here. So for LA, I've got this 8.83% because I got to go 2 places past the decimal to start with. Then I got to decide, rounding to the 10th place or 1 place past the decimal, is that going to stay as 8.8% or is it going to round up to 8.9%? And that 3 says keep it at 8.8%. So we just keep the rounding the same, 8.8%. So that would be the coefficient of variation for LA. And you kind of see that there's slightly a little bit more variation in Denver than LA, but I don't know if that is really a big difference percentage-wise. It's slightly, but not a big difference in variation. So they're very close together. So that's how we can do the coefficient of variation using the TI-84.